Assalamualaikum and good morning everyone. My name is FATIN AFIQAH binti ZAINALABIDin, and today I will be presenting my assignment on understanding viscosity, density and correspondability and their impact on engineering system. This topic is essential for designing efficient and safe fluid-based system used in industry such as oil and gas, maritime and energy. Fluid properties determine how fluid behave under different conditions. In engineering, we rely on this knowledge to design systems like pipeline, pump, cooling network, and more. In this presentation, I will focus on three key fluid properties, which is viscosity, density, and compressibility. I will explain what they are, where they are applied, and the challenge they can create in real-world engineering scenario. Fluid. A fluid is a substance that no distinct structure and easily responds to external pressure. A fluid is any liquid, gas, or substance that when at rest cannot endure at shearing or tangential force, such as water, air, or mercury. Let's start with viscosity. Viscosity is the internal resistance of a fluid to flow. It represents a friction between layers of fluid as they are moved past each other. It is measured in Pascal second and it's represented by the equation Tau, rho, and du over dy, where Tau is the shear stress, rho is the dynamic viscosity, and du over dy is the velocity gradient. A real-world example is the Trans-Alaska pipeline, which transports crude oil due to its high viscosity in cold temperature. The pipeline uses heater and powerful pumps to reduce resistance and ensure smooth flow. As you know, high viscosity can do a strong internal friction and flow slower. Also, low viscosity is less internal resistance and flow faster. Next is density, defined as mass per unit volume. Density is crucial in systems where buoyancy matters, such as in the ship and submarine. For instance, submarines control their depth and adjusting water in blast tank, changing their overall density. This principle follows Archimedes' law and object fluid. If it's less than the fluid around it. Is compressibility referred to how much a fluid volume changes under pressure. This is mostly significant in gases. Isothermal compressibility is present as a beta. In gas pipeline, pressure change can lead to the large volume and density shift, making it difficult to maintain steady flow. This fluctuation create complex challenge in system design and control. Liquid is generally considered incompressibility because their volume change negligible under the pressure. For engineering application in viscosity, one of the most well-known real-world use in the Trans-Alaska pipeline system, transporting crude oil for approximately 1,287 km. The viscosity of crude oil is far higher at the reduced ambient temperature that prevail in Alaska. To make efficient transport feasible, the pipeline include heating station and mechanical pump which reduce the viscosity of the oil by maintaining it at an elevated temperature along the pipe. This reduces pressure drop and power usage as well as wax disposing, which can restrict the flow. For density in buoyancy and fluid flow system, for submarine, this is achieved through blast tank, which can be loaded with water to become heavier and or load with air to become lighter and rise. The overall density of the submarine must be precisely matched against the density of seawater, varying with salinity and temperature itself. Engineers apply this relationship to ensure safe surfacing and device operation. Compressibility also becomes a dominant feature of gas dynamics, especially as fluid undergo high pressure and temperature change. Compressibility influences the behavior of the gas within the natural gas pipeline system during the transportation over the long distance. Attitude change, ambient temperature change, and valve action cause a pressure to drop, resulting in the change in the gas velocity density. Engineers use compressibility factor Z, an equation of states such as an ideal gas law or the real gas model to predict and regulate flow behavior accurately. In addition, in aerospace and jet product propulsion, compressibility effects are more pronounced. Shock wave and the pressure discontinuous are experienced at high Mach number, and to avoid structural failure and yield effective propulsion. Carefully analyze the compressible flow is required. Techniques such as computer fluid dynamics (CFD) are employed for simulating the effect and making design choice. The challenge is managing compressibility in gas transport system because gas expand and they contract significantly with the pressure. Maintaining a constant flow become difficult, especially across long distance with variable elevation and temperature. Compressibility effect: volumetric flow rate, which reduces as the pressure increase; density, which varies along the pipe length, especially under oscillation ambience and operating condition; and lastly, pressure distribution, which become non-linear and highly sensitive to the flow disturbance or elevation change. Engineering solution to mitigate compressibility effect. First, compressor station to boost the gas pressure at the interval so that the pressure reduction due to the friction and elevation is compensated. Next, real gas equation and CFD models application. Real gas equation and CFD application to predict flow behavior. Lastly, automate control system. SCADA system to monitor and automatically adjust pressure and flow in the real time. This solution can help ensure safe and efficient operation despite the complexities caused by the compressibility. Conclusion: viscosity, density, and compressibility are not just theoretical, but they are central to solving real-world engineering problems. Whether transporting oil, design submarine, or managing gas pipeline, understanding these properties allow engineers to optimize systems for performance, safety, and sustainability. This principle will continue to be vital as industry moves toward more efficient and innovation design. So, these are the references that I use to make a slide and the report for understanding the fluid properties. So, that's all for me. Thank you for the listening.